So, when I was starting with center of mass, I gave you this example of chalk, that when I throw the chalk actually makes a rotational as well as a translation motion. And to analyze this motion, it's very complex with pure kinematics. So we study center of mass. So this is an experimental demonstration where they are throwing the racket. And you can see that the end point of the racket is actually making a rotational as well as a translation motion. But the center of mass is actually doing a projectile motion. And we have already made the equations for projectile. So it's very easy to analyze now, right? And what was center of mass? Center of mass in layman terms could be, it's actually a point where whole mass of the body can be assumed to be concentrated at. Notice that I'm saying that it is assumed, right? But actually it is not there, right? So the whole mass is actually distributed along the length, right? So there would be different weights acting along the length, but if you take the torque of all those forces about the center of mass, they cancel out, so it becomes zero, and hence we are able to balance it, right? Because for equilibrium the net torque should be zero as well as the net force should be zero, right? So that's why we are able to balance anything at center of mass.